So first off, welcome everyone to this session on electrifying long-distance coach systems. Cross-country on Electrons. I'm Wendy Reuter, and if you were here last night, you already know I'm VP of Member Value at the Canadian Urban Transit Association. Canadian Urban Transit Association. So what's my interest in long-distance coaches? Well, there's two main reasons. As an association, our members are interested in this topic, and also we're really interested in how Canadians move around. Our members have a vast interest, obviously, in vehicles and propulsion. CUTA has twice as many business members as transit systems, and many of them are private manufacturers, suppliers, operators into this space. And they're also operating not only transit and supplying into transit, but also into school bus and motor coach as well. So there's a great deal of interplay across these parts of the industry. And secondly, with CUTA's interest in integrated urban mobility, we are here to help inspire the evolution of how people can move around according to their own needs. And that requires a number of different elements, from infrastructure, built design, to multiple modes. We did struggle with the term urban when we came up with that term, integrated urban mobility. Seems like it's leaving a whole lot of people out. And we struggled with it in our name as well, Canadian Urban Transit Association. But what we came down to is that people need to move around for all of the same reasons. They choose to take transit, they choose to move around because they need and want to go to jobs, education, healthcare, they need access to social services, recreation, and commerce. And they choose transit maybe because of economic reasons, maybe philosophical reasons, maybe convenience reasons. And sometimes some of them need to move around in these ways. But all of these reasons are real, whether we live in a built urban environment or we live in a smaller community across Canada. We still all need to move around, and we want to have choices in how we move around. So at CUTA, we landed on resolving this question about urban in our own minds to say, well, let's take StatsCan definition of urban areas being congregations of 2,000 people or more. And let's think about how do we help Canadians that are congregated in these areas move around more fully. So we have about 2,000 communities in Canada like that. 130 of them are served by public transit. So what about the rest? How do they move around? So let's talk those numbers. That means those 10 million that aren't served in areas with public transit still need to move around, and what choices are we giving them? We know from our coach providers that there are about 1,500 coach vehicles in Canada right now. So when we think about how do we help people move around outside of the really large urban areas, we do think about communities like Chestermere, that Josipa mentioned yesterday, just outside of Calgary, rapidly growing community, recently identified as a municipality and currently 20,000. So how do those individuals in that community move about according to their own needs in their own community, and how do they get access to the services that they may need or want in Calgary? So I'm really excited about this session and this panel. I don't know where else this topic is being discussed. So let's find out where we are in bringing electrification to the rest of Canada. I'd like to welcome our panelists up. So with us today to help us explore this question, we have Michael McDonald from MCI, and I'll give more introductions. Daljit Balwa from Ballard Power, and John Stipovy from PWT. So to start this session, we're recognizing that Canada is big, it's vast, it's expansive. The highways can seem never-ending, but Canadians need to move around. Whether it's crossing the greater Toronto and Hamilton area from Oshawa to Hamilton to get to work for the day, or to head from Calgary to Edmonton on a day trip with one's family, coach bus systems move Canadians in important ways, but they're hard to electrify. The energy requirements, the charging power levels, and complicated bus designs that need to accommodate suitcases, people actually taking off their coats and settling in for a while, and the infrastructure challenges across multi-jurisdictional highways all combine to make long-distance coach electrification pretty tough. So this panel is going to discuss how to crack the nut of long-distance coach electrification and how to bring electric mobility to Canadians across all highways, country roads, and coach bus routes in the future. Right? So let me first turn the mic over to Michael McDonald. Michael is Sustainable Transportation Specialist with MCI. Michael received his doctorate in electrochemistry and material science from the Department of Chemistry at the University of Manitoba. Michael's research focused on the development of solid-state electrolytes for direct solar-to-fuels technology. And following this, Michael worked in the lab of Professor Paula Hammond as postdoctoral fellow in the Department of Chemical Engineering at MIT. Michael's work included development of new highly functional material for lithium-ion battery iodes, for which he holds a patent. He has a total of 9 publications as a result of these positions, and following his appointment at MIT, he joined MCI as the electric and battery transportation specialist to contribute his expertise to this technology and the electrification of coach and buses. So Michael, I'm hoping from you we will hear a little bit about the challenges of rolling out electric coach and what we see with on-road deployment.
Great, thank you so much, Wendy, for the kind introduction, and I just wanted to say that I'm so excited to be here today. The U in both QTRIC and CUDA stands for urban, and so I think it's pretty groundbreaking that we're here today to take that beyond the city and face some new challenges. So just a little bit of background on MCI. If you're not familiar with it, we've been a Winnipeg company since 1933, so we have over 85 plus years of engineering. We also have a large US presence as well. There was a period of our time where we were actually owned by Greyhound, and I think that that's how most of you may associate motor coach applications. It's sort of that cross-country type application. And then more recently, we were acquired by the NFI group, so we have that brethren as well, and that's really exciting. We are really excited to be the coach in that largest coach and bus OEM in North America. So what is a motor coach? So if you're not familiar with it, the easiest definition of it is that it is a bus built for the highway. It's over the road. You're going to have longer distances involved. There's an expectation that you're going to have storage. It needs to be rugged to handle those types of conditions, and you're going to have all sorts of fancy amenities like armrests, footrests, even in some cases some fancy lighting as well, depending on exactly what our customers demand. So who are our customers? So like I already mentioned, we have the more obvious, the cross-country tours. Maybe in your younger days, if you played on a team, you may have traveled with that team, from one city to the next or one arena to the next. Probably more relevant to everybody in this room is the public transit commuting, where basically a transit agency would own a fleet of motor coaches, and it'd be used for longer distance applications, but still within the public transit realm. Employee shuttles, probably the best case example of this is in the Bay Area, where you have these really large tech companies like the Apples, Googles, and Facebooks, where they have these massive campuses, and it actually makes sense for the employer to form their own fleet to get their employees from the city out to these campuses and back. And then there's some mid-range applications. Maybe this, an example in Canada might be the ability to go, between Edmonton and Calgary on a longer sort of daily commute or weekly trip. So as we all know, battery electric transportation, as we try to take on, these markets with electric, what are our limitations? Again, like Josip said, these are old conversations, but they hold true to battery electric coaches as well, is energy density and refuel time. There's no way around that, and that's going to be ever more present in the market that we're working in. So therefore, the first markets that we need to tackle are going to have to match the technology that we have available. So they're going to have to be applications where you're going reasonable distances, where you have opportunities built into your duty cycle to recharge, and then that, of course, is all augmented by exactly how difficult your duty cycle is to begin with. So how does that jive with our traditional applications? So cross-country tours, I have a red dot there to symbolize that, maybe we're not quite there yet. That's going to definitely be the most challenging type of application. Athletics transportation and that sort of mid-range transportation, that probably be, maybe at the limit of what we're able to do with our current ranges. But the public transit area and those employee shuttles I was describing would be the perfect application to tackle first with electric, given that, again, you have something closer to a more normal route, which like you would in the transit public space. You're going to have heavy usage earlier on in the day, and then as well later on during evening rush hour, so you have some downtime in between to do a recharge. It just makes sense for us. So we need to get the electric drive systems that are able to match what we need and what our customers expect from a motor coach. So what are those things? So we, just like when you're electrifying any sort of vehicle, you have a traction motor, power electronics, accessories, et cetera, and those need to be able to handle the demands of the motor coach. Batteries, of course, is my area of expertise, so there's going to be really heavy usage, and I know that in the transit sector, they're going to talk about needing batteries to have a very strong cycle life as being their number one priority, and that's all well and good because you have, very fixed routes in transit, and so therefore, even if your battery doesn't have the highest energy density, you can design your infrastructure to meet your demand. With motor coaches, where you maybe need to move a little bit off of that and go longer distances, battery or energy density is equally important, and so finding a battery that's able to meet those demands, that's tough. So MCI's main task is to basically take that technology and integrate it within our proven coach frame that we spent 85 plus years developing. Our strategy for that is to partner with some of the best suppliers of this technology and really be on the cutting edge, use our integration expertise to do that, and also stand on the shoulders of giants because New Flyer has been doing this for far longer than we have, and so we get an opportunity to stand on the shoulders of giants as we tackle this gargantuan task, being brothers and sisters in the NFI group. So we're really excited that last year we completed the build of our first proof of concept 100% battery electric motor coach, 450 kilowatt hours. As you can kind of see, I'm showing the anatomy over there. You can kind of see that it's an exercise in basically juggling all these batteries that you need, obviously with the energy density differences between batteries and diesel fuel, whereas you normally store all of your energy within the space of a fuel tank. We now have a bunch of batteries that we need to balance on there as well as those electric accessories. We're experimenting with two different types of battery supplier, actually, and then shown to your right is our production target where we have a different battery on there. And what I'm trying to show you here is as soon as you change supplier, the form factor of each individual cell is going to change. So each module size is going to change, your packing strategy is going to change, and then it's basically this domino effect of trying to fit all these batteries along with your electric components. And so that's why our production target actually looks far different than the lessons that we learned in our proof of concept exercise. So we're really happy with the improvement on that, and we're excited to keep moving forward. Just a couple months ago, we were really excited to unveil the completion of our very first electrified CRT LE. The LE stands for low entry, and this is actually a new variant to the market. In a typical motor coach, everything is high floor, and so what we've actually done here is we have a low floor vestibule with a ramp and bipart door. It's first in the industry, and so that really lends itself to full inclusivity and accessibility for all of our customers. And then we've gone and electrified that. So the challenge there is that now we have an area where we normally love to shove a ton of batteries that we have to work around. And so again, it's a domino effect theme. But what we've ultimately achieved here, and if you guys were able to come out on Monday to New Flyer to see the site, you would have gotten to see this beast up close, and we're really happy that we found a really nice mix of all electric drive and accessibility. So this will be really perfect for the public sector commuting market. I'm running low on time, so I just wanted to give a quick note on our charging strategy. So far, we've really just played around with depot-style charging. So we've worked with ABB and a 150 kilowatt charger following J1772. So the whole idea of interoperability between different OEMs of both chargers and coaches and buses, that is a central theme to our group strategy. And even though this seems kind of slow for such a large vehicle, that actually jives really well with what our applications demand. So where we have heavy use during morning and evening rush hour, and we have a bunch of downtime during the day, that's a perfect opportunity to top up for that evening shift. And then we can do overnight charging. And this also jives really well with the types of batteries that we need to use. So if we have more energy-weighted style batteries. Those perform better in terms of their entire lifetime if we're charging them at a slower speed and we're not constantly zapping them with tons and tons of power at a time. So that'll lend itself to a longer life. That said, we're always really excited to work with the industry as the industry evolves. Every year we see faster and faster charging. We see the standards improving. And so therefore we're really happy to evolve with that. And we're always really open to staying with the best technology available for charging. And then a final note, another advantage of being a part of the NFI group is that we get to leverage their New Flyer Infrastructure Solutions team. That's a team that's going to come down to your site, do a site visit, a full assessment, the make-ready work, and basically design and implement all of the infrastructure needs that you would have for your fleet. So that isn't only going to cover the electrification of the transit bus side, but if you operate a fleet of motor coaches, you're going to cover that as well. And so we're really excited to be able to leverage that as a part of our business model. So lastly, our next steps in the short run, it's going to be to complete the exhaustive test plans that we have for our 2 demos that we have out there, learn lots of lessons, build more of these things as we lead up to our start of production late next year. We're obviously very excited about that. And then to keep testing, learning more, and then eventually electrifying new variants as well until we can go all electric. In the long run, some lessons learned are that, in general, in the motor coach industry, we're going to be, it's very much a wait and see with the technology. We're integrators, and so we rely very heavily on innovation that's happening on the electric componentry side. For longer range applications, I had that red dot cross country, is something like a fuel cell coach going to be in our game plan, something to consider. And I'm sure Daljeet right after me is going to have some excellent words that are going to back that up. And then the rest of it's going to be a bit of a wait-and-see game. We're really excited to get this in the hands of customers, see how the market embraces it, see how their friends across the street see that they're embracing it. What's the regulatory climate going to be like, and how is this going to have an effect on the coach market? What sort of preferences are our customers going to demand? And is zero-emission technology going to be able to actually walk the walk in the industry? We get lots of promises over the performance of all of these different components that we're buying and we're getting ourselves into, but how are they actually going to perform in the field over a 12-year length? And finally, this last point, I think this really sums it up nicely. Because we're kind of forced to follow the way of the technology, the better the technology that comes out, the greater the breadth of applications that we're going to be able to cover. So I'm really excited to be a part of this panel, and I think that the fact that I've been to so many of these conferences and we haven't really discussed the coach side of it, we're already breaking new ground. So I'm really excited to participate in this conversation with my fellow panelists. So thanks very much.
Thank you, Mike. That was a great way to kick off this session. Next, I'd like to welcome up Daljeet Bawa. Daljeet is the Manager of Business Development at Ballard Power Systems. Daljeet joined Ballard in August of 1999. You've been working on this for quite some time as Senior Field Service Engineer. Daljeet has managed field trials of both stationary and transportation fuel systems. Okay. He is a mechanical marine engineer by profession, and he's a graduate engineer from the Institution of Engineers, India, and has a master's diploma in diesel propulsion plants from the Naval War Academy in Russia. So Daljeet, I'm hoping that we'll be hearing from you about the potential for hydrogen and how it could be used in this application.
Thank you, Wendy. Thanks for the kind introductions, and thank you to the audience for giving us an opportunity to talk about Ballard and talk about fuel cells. To begin with, for the benefit of audience who don't know what's a fuel cell is a device that converts the chemical energy of hydrogen directly into electricity via a catalytic reaction. There is no combustion, so it's a zero-emission technology. There are very few moving parts. That's why the fuel cell drive system is very efficient, normally above 50%. As you know, like in a diesel engine, you convert the chemical energy of diesel into mechanical. Here you convert the chemical energy of hydrogen directly into electricity. So that's what we do. There are several types of fuel cell. We believe only in proton exchange membrane type of fuel cell. because that's the only fuel cell that can do load following. Basically, the turn down ratio is great. It can operate at 100%. It can operate at 10%. How do I go back and forth? The arrow? This one? Okay. So just a word about Ballard. We've been in business for 40 years. In fact, this is our 40th year anniversary. We are the only startup company which refuses to die down. 700 employees. If you saw the slide last year, it was about 500 employees. So we are growing with all the growth in the investment into fuel cell industry. We've spent about $1 billion in the research and development of proton exchange membrane fuel cell. That is why we have an access to 1,500 or more patents. We are listed on NASDAQ as well as on TSX, and by 23rd September, we will be listed on S&P TSX as well. We have several strategic investors, one of them being Weichai. Weichai is a Chinese manufacturer. They're the largest diesel engine manufacturer in the world, several times bigger than Cummins. Now, this investment started a chain reaction in the fuel cell industry. As if you have kept note, Weichai invested about $200 million into Ballard last November. Bosch invested into PowerCell, a company out of Sweden. Cummins went and bought Hydrogenics about 2 months ago. And more recently, Fiat, Iveco Group, has invested into Nikola, the fuel cell truck company. So this is all very good news for the fuel cell industry that the mainstream player, system integrator, or system manufacturers are now getting into the business of fuel cells. We supply technology for various applications: transit, trucks, trains, ships, and the forklifts. We also, by way of our $1 billion, we supply a lot of technical solutions expertise to various companies. We have a running contract with the VW and Volkswagen to develop a fuel cell for them. And we do work packages for a lot of other auto OEMs because we have those access to the various patents. And several megawatts of power supplied, but the important thing to note is 25 million kilometers in actual revenue service with our technology. That's the proof of the technology working. And lastly is the durability, that our fuel cells are lasting more than 30,000 hours, which is almost half the life of the bus. So that's the strength of the technology. So to talk about basically challenges about the long-haul coaches is how to deliver a long range, without compromising the vehicle safety and a whole lot of other stuff. Okay, we're going to stop this one, go here. So value proposition of the fuel cell coach, obviously you need long range. You want to have it to operate in all weather condition. If you have to operate, let us say, between Banff to Edmonton or Vancouver to Whistler, 400 kilometers of range up and down. And then consistent performance as well as then faster refueling, because you can't afford to wait for a couple of hours to charge the bus, whether you're on whichever side you are on. So we do work with the MCI and a couple of other OEMs. We have developed a new fuel cell which we launched last June at one of the UITPs. And this fuel cell we supply between 60 to 200 kilowatts of power depending upon the requirement of a customer, so that you can integrate it into a bus or a coach. And the fuel cell that we are coming now basically can be oriented in several directions so that the packaging becomes relatively easier. There are challenges around the hydrogen storage on these coaches because ultimately the range is not dictated by the fuel cell, but by the hydrogen the amount of hydrogen that you can carry on the coach. So there are several things in works, like doing maybe a 700 bar system, or maybe have some flex pipes, liquid carriers for hydrogen. That's being developed in Germany. Also, there's the possibility of carrying cryo-compressed hydrogen on this thing so that you can get a range of about 1,000 kilometers. All those things are in the works, and we hope that in the next 3 to 5 years that should realize. We also have integrated fuel cell on the double-decker buses, especially the love for the UK to the double-decker buses. And recently, London, UK has placed an order for 20 fuel cell double-decker buses on Wrightbus out of Ireland. And also Aberdeen in Scotland has placed an order for 15 double-decker buses on Wrightbus. And we are expecting basically Liverpool and other cities also to go the double-decker fuel cell buses. We integrate fuel cell on both double-deckers, that is Wrightbus as well as the Alexander Dennis, which is now part of New Flyer Group. And Alexander Dennis has a manufacturing here in Ontario as well as in the US, and they do meet the Buy America regulation. So we expect that double-deckers will also become very, very prominent, and you operate double-deckers here in the Ontario area between Toronto to Hamilton and all those places. So I think fuel cell will play a key role in that when you have to go zero emission on the double-decker buses. So just a question as to why hydrogen. It's any fuel has to be respected, that's one thing. But it's a safe fuel, by way of that 25 million kilometers of actual revenue service with the grace of God, no loss of life, no loss of equipment. That speaks about the safety of the entire drive system. And it can be produced whichever way you want. You can have produced locally at a depot, or you can have it trucked in. So no issue with that part. So the recommendation basically to the transit agencies and to the OEMs is that we will work with you to integrate our technology into this. And if you have to go above a certain range, say 300 miles plus, then what you are looking, especially on a zero-emission drive, then you have no other choice but to go a fuel cell and hybrid drive. Recently, a New Flyer bus was tested at the Orange County in California, where a proven range of 350 miles was delivered. So that's the benefit that you get with the fuel cell hybrid drive system. And it is a tested and validated technology, tested and validated in Brazil, India, China, Palm Springs, Canton, Ohio, London, Oslo, you name it, and we have it. Thank you so much for your attention.
Thank you, Daljit. All right, so I'm going to now introduce our third and final panelist. John Stopovi is the Director of Business Development from Pacific Western Transportation. John has been with PWT for almost 12 years, starting in operations and later general manager for their flagship luxury intercity motor coach, Red Arrow. John's current role is Director of Business Development. He's focused on broadening the reach of the organization. And I think you've seen John talk on a number of subjects, broadening the capabilities within the industry, including electric autonomous shuttles, microtransit, and demand responsive solutions. Prior to joining PWT, John was in the manufacturing industry. So he brings that expertise into his talk as well. And his first exposure to transportation was with International Trucks. John was raised in New York City. He knows about urban environments, but he does consider himself an Edmontonian. So from John, we're going to hear a little bit about operator perspectives in this environment and the challenges either with battery electric or fuel cell on electric coach. Welcome, John.
Thanks, Wendy, and thanks everyone for the opportunity to talk a little bit about our organization, kind of some of our thoughts in this space. So Pacific Western Transportation is a privately held, family-run business. We're the largest privately held people transportation company in Canada. Have been around since 1967. And we operate in a number of different sectors. So school busing's a big space for us, and transit, all sorts of coach work, including employee transportation, intercity motor coach, charter and tour, and again, a lot in that employee transportation sector. Safety being our number one core value as we transport people. We won't get too much into this, but these are the values of our founder, and this is how we operate our business on a daily basis. So in the coach space, and thinking about intercity, we have three main sort of services for long distance intercity. We have our Red Arrow brand, which is in Alberta. It's a higher-end luxury service. There's 36 seats. It's think about business class on an airline. That's the experience you get with Red Arrow. Then we have our e-bus service, which is a little bit more of a value line service, so caters particularly well to students. That's in Alberta, and we introduced it into British Columbia in the fall of 2018. And then BC Bus North, which is actually under contract to BC Transit, and it operates the northern BC routes. I think a lot of us have heard about the highway tiers issues and things like that. So BC Transit implemented this service to mitigate some of those risks in that area. All these services are longer distance, minimum 100-mile trips, but trips typically tend to be kind of in that 200 to 300-mile range. So we are a believer in alternative fuels. PWT actually owns the largest alternative fuel fleet in the country and second largest in North America. Primarily that's, again, on the school bus side, where propane is an alternative fuel that's clean and that we've used for a long time. We've had expertise with hydrogen fuel cell with BC Transit operating the Whistler Transit fleet of 5 hydrogen fuel cell buses for 5 years. That was kind of that part of that Bannock Olympic trials. We operate a handful of electric BYD buses in St. Albert Transit, so we have exposure to this space. Again, these are some of the again, school bus propane. That's the St. Albert Transit electric bus, and of course our autonomous shuttle Ella, which is an electric shuttle as well. So some of the challenges, I think, Michael's touched on a few of them, but I mean, really thinking about private sector and longer distance. So whether it's employee transportation or commuter, which is typically a little bit shorter, in private sector, we have to think about utilization of that asset. So an asset sits, it essentially costs us money. The few contracts out there will make a difference because, again, if contracts are with municipalities, they're funded and things like that. But, it's difficult for, say, Red Arrow to go to Calgary, park the coach there for a couple hours, let it charge to make its trip back. We need to think about, okay, so that coach may get to Calgary, then needs to go to Lethbridge. Maybe it does a quick, dinner transfer and then heads back to Edmonton. So our downtime with coaches is not a good thing. And I think anyone in private sector or even, probably in a transit agency knows kind of that operations and maintenance battle back and forth of we need to maintain, we need to operate, we need to generate revenue, things like that. So I think that's a significant challenge for us in private sector. Thinking about longer distance trips, as Wendy noted, this isn't a few blocks, hop on, hop off transit. This is, I'm going to get comfortable, I'm going to put my coat away, I'm going to get my laptop out, I'm going to plug my phone in. I may have luggage that needs to go in. So we think about the capacity, just physical, spatial capacity for all these things, especially luggage, charter and tour or athletics. We also have to think about kind of that power consumption as, 55, 56 people plug in laptops and batteries and or their devices and things like that. And again, as I said, kind of that cost recovery. When you think about, even comparing an electric school bus today to a propane-fueled school bus, it's about 4 times the cost. And school boards have a difficult time as it is, with services and things like that. So to go to them and say, okay, well, that trip that cost you X is now going to be 4 times that is just, again, not palatable. So again, these are just some of the general challenges that we in private sector face in alternative fuels and electrification. So the outlook, I mean, I think We think there needs to be continued investment, so definitely from federal, provincial levels. I mean, I think the technology is certainly evolving. I think battery densities and fuel cells are the technology's advancing, and I think for us, we're continuing to look at it. We believe in it, but it needs to advance further. And again, with that advancement, not only we think we're going to get better capacity and utilization, but the cost should start getting to a point where it makes sense for private sector. And again, like I said, with government and the funding, I think there needs to be more engagement at all levels of government. I mean, if we are going to have a clean air policy and are going to work towards this, there needs to be some thought about private sector funding, because private sector does make up the greatest amount, especially on the motor coach side. There's probably 2,000 or so motor coaches in the country, maybe a little bit more, and 90% of them are owned by private sector. So, if provinces, if the federal government wants to advance this and not only take cars off the road, which we do with motor coach, but to continue to advance the clean air solution, they need to start thinking about funding for private sector as well, which may advance that quicker and further along. Thank you.
Thank you, John. So perspectives from an operator. So we've heard from our panelists the challenges of rolling out the technology on existing motor coach. We've heard about the opportunities for using hydrogen, and we've heard some operator perspectives. I think when we hear the opportunities about manufacturing, the role around manufacturers and being integrators and following the technology is a theme that we heard throughout our speakers. But there are living demos right now with the motor coach that we see with MCI. We're hearing from Ballard that the fuel cell technology is there. It's demonstrated as safe. It's demonstrated as having the range. I think I heard capability is 350 miles. Quick math, 600 kilometers. Operators, we're hearing a need for 100 to 200 miles. Sounds like we're in the range of the technology starting to fit the needs. How do we bring it all together? So I have a few questions to kick off the questions with the panel, and then we'll open it up to the audience and explore this question a little bit more. So you've had a chance to hear from each other as well. And I know you're all well familiar probably with each other's capabilities. Hearing it from the audience perspective now, and where we're at today, what is the biggest challenge in electrifying coach systems? The coach systems, the buses, the charging systems. How do you see this being overcome? So we'll follow the rest of the session's model of like a 30-second answer.
Okay, so I guess the first point I'll make is the most boring, and that's obviously range is probably a huge issue. Right, we do have the capability technically, but one of the issues with the motor coach sector is that the application breadth is so large. There's, when you're selling a transit bus, for the most part, even though, it was said yesterday that when you've seen one transit site, you've seen one, that couldn't be more true than for a motor coach. And so we need to build a one-size-fits-all model, and that's just not really possible. And so trying to adopt that technology in the best possible way that it meets most of those applications, that's definitely the biggest technical challenge as an integrator. Like, do you want the most amount of batteries every single time? Probably not. You also need to be cognizant that there are going to be times when a customer is going to want to take it off its typical duty cycle and have it perform. So in that case, yeah, you do need more batteries. And so it's finding that balance that's extremely difficult.
Terrific. Yeah, thanks, Mike. And of course, we're hearing from John, too. The operator wants to get full utility out of these vehicles, right? We don't want lazy assets. So if we're going to build that electric coach, how can we make it useful for a variety of uses across a variety of time? So over to you, John.
Yeah, I think I'll echo what Michael said. It's about capacity of the batteries, longevity and range of the coach. for us, an asset that sits costs us money, so we need to have it on the road, and how can we do that with, more capacity, minimal charge times? I mean, I think that's probably the biggest challenge.
Perfect. And Baljeet.
Yeah, I think is it working?
It is,
Okay.
yeah.
But I think the first thing is that the government will have to step in and provide some guidelines on the operation of zero-emission coaches. I can tell you, even if we were to give you the best of the coach with almost a better fuel consumption than what you're doing today, if I am an operator, why would I want to change? Unless, like California, we have regulation, like China, if we insist, no, you got to have 20, 30, or whatever the percentage is. So the government policies and directions are very important so that the zero-emission transportation can be implemented.
Okay, so we're hearing about the technology changes, the range that can suit multiple purposes across a variety of customer needs. But now we're talking about adoption. Technically, we've got some thinking to do, but now how would we get that adoption? And this is getting through issues around cost of the upfront capital, but then also, as we're hearing from the operator, cost recovery. We're generally working in a private environment with motor coach as opposed to an urban transit environment where the assets tend to be publicly owned. So there's a different operating model here, and how do we overcome that? So I'm hearing suggestions that we need to be working at a federal level and have it be having some mandate down on adoption. Any other thoughts on how we might move adoption forward?
I think the way yesterday John mentioned from Proterra that P3, or private investment is the way that will work, because we totally understand that the companies which are operating are on a shoestring budget, and the cities themselves have got, either they increase the taxes, which no one would like, including I. So I think a P3 partnership is the best way to go so that we can implement the zero emission technology.
Yeah, I have one more comment too. So Wendy, I think you actually had it half right when you were talking about, well, you're totally right that there's a very large part of the market that is private, and so they have to have that, that economic model in order to go forward. But the other half of it is that, a good chunk of our business is operated by public transit agencies, and so you are going to see lots of government regulation and public mandates to go that direction. So let's let bus operators adopt this. Well, first of all, they're going to adopt transit bus technology. So they're going to learn about running electric transit buses. They're going to develop infrastructure. Then they're going to move on to the motor coach. And so once they were able to demonstrate in a public space that an electric motor coach is feasible and there's a good business case behind it, then the private side of it, guys like PWT, they're going to see that and they're going to say, you know what, we can do it too. We have some of the lessons learned in place, and we can piggyback off of that. So it's going to be a show me first, I think.
Yeah, John, your thoughts on this?
Yeah, again, it's for private sector. Again, thinking about our inner city service. I mean, even let's say it's twice the cost to go electric, and that cost can also mean more spares to have buses available to do the same amount of miles as we do with traditional diesel buses. So there's that cost side. So how do we pass that on to the public, right, that's utilizing it? And it's pretty hard to say, okay, well, your ticket that was $70 is going to be $150 because we're electric and we're doing all this. I mean, I think federally, provincially, we have opportunity to encourage public usage with either tax breaks or incentives. So you think about what California is doing with the pre-tax credits and things like that. So that allows the Googles and the Facebooks of the world to put people on buses, mitigate single occupancy vehicles on the roadways. We don't really do a good enough job of that in our country, in provinces. So I think there's opportunities to encourage the individuals, because I think citizens in general can drive a lot of that as well if there's some methods for them to actually benefit from it. And again, cost is an issue for some people. So, if there's some of that available, then it could help private sector. And again, we think private sector can advance as well.
Yeah, well, I appreciate you bringing up those comments because we certainly know on the public sector side of the public transit side of things, the higher the cost, the lower the ridership, right? So, how much of it is borne by the individual rider on the coach system as well is going to be really relevant. So, if we take it back just in terms of just comparison of public transit and where the technology is at, can you give our audience a sense of the relative degree of efficiency of electrifying coach vehicles versus public transit vehicles? We've talked a lot about efficiency on the public transit side of things. How do coaches compare?
I will tell you a general statement, and this was made by Daimler CEO at the ACT Expo held in Long Beach earlier in May this year. He said a diesel truck has 32,000 moving parts. An electric truck has 9,000 moving parts. And same thing is true even for the diesel and the electrical coach as well. Like a diesel coach has got many moving parts as compared to an electric coach. So efficiency is explained in those terms.
Right. So being one of the only manufacturers actually in the world that's built a 100% electric coach that would be meant to fare on the highway, I'm about to disappoint you in saying that we're only a few months away from actually having real field data. I would have loved to have come here and given a fantastic presentation like some of those that were given yesterday. We actually get to see field data in the highway and get an idea of those, those sexy numbers that we're always looking for. Unfortunately, our testing schedule didn't permit for that. But aside from that, I think that it's a really important point that's often overlooked is, efficiency on the highway. One of the reasons why we're so excited to do electric transit buses is because they're operating in city environments, and we know that technically it makes the most sense to do electric drive, and that's for two reasons. The first being that we can take advantage of regenerative braking, and so we're doing a lot of stop-start in the city, so that lends itself to that, as well as electric motors perform extremely well under low speeds, and so you avoid having to use a transmission. But what about if you're using an application like a coach where there's a good amount of time that you're expected to be on the highway? What's your efficiency there? Mm-hmm. It drops off, to be entirely honest with you. Diesel engines perform much better at faster speeds. So while it may seem like we're building fancy buses here, there's a good part of the coach business that's a lot more like the trucking business. And so the trucking business is also being slowly electrified as well because there's a really good business case there. They have really high OPEX costs. And so they're developing technology, electric drive related, that suits their application. So things like adding one more gear. So when you're operating at high speeds, even though we want to avoid a full transmission, we can take that motor and put it at its peak efficiency even at higher speeds. And so that might be technology that we want to adopt in the coach industry as well.
John?
I mean, obviously we're not manufacturing experts being operators, but I think the one comment I can make is thinking about from a maintenance perspective, it's also a different skill set. I mean, we hire traditional mechanics, whether they're light duty or heavy duty, but thinking about some of the places where we do operate and maintain electric vehicles, it's a very different skill set. So there's a different type of maintenance personnel that you're hiring. We're hiring people with a little bit more kind of engineering background, electrical background versus kind of your true red seal mechanics kind of thing. So again, there's a shift happening, and again, it's that balance. So if you have one or two buses, how do you do that? Because a mechanic, typically it's maybe 1 to 15 mechanics to motor coaches kind of thing. So I think that's just another area of consideration.
Yeah, so John, on that, we know that with the movement towards electric buses on the public transit side, we're going to need different skills in the shop. As a private operator that's working across school bus, motor coach, and transit, we think about those different skills that are needed. Will there be a difference in the skills that are needed between electrified transit buses and electrified motor coach? How distinct might that be, or can we look for skills that are quite similar?
Again, it's hard to say. We don't have electric coaches, so we have no data on that. I mean, maybe Michael can comment on that, but from what we've seen in transit, for a transit style bus versus even Ella, the skill sets are similar. They're very, again, engineering based. Like we're trying to solve those types of things, and our when we're trying to diagnose, you're diagnosing in a very different way than you would a traditional, diesel engine or a gas engine kind of thing. So definitely, in our opinion, a different skill set, but one that can apply whether it's, coach or school bus or an ALA or whatever it is. Electrification is electrification week. That's, I think, our initial thought right now anyway.
Okay. Terrific. Thank you. I see a question here in the audience. Michael.
Thanks, Wendy. This is an interesting topic, and I appreciate the scale of long distance being on the program. I know the subject matter is on electrification, but I'd be interested in the panel's perspectives on a bit of a different angle, which is that of the concept of intercity and intercommunity mobility, which is rapidly becoming a big challenge for this country, and in particular how the concept of the 45-foot highway coach fits into those needs. We've seen in recent years Acadian lines abandoning Atlantic Canada. We've seen STC shut down in Saskatchewan. We've seen Greyhound pull out of the prairies. And the poor soul who lives in a small community, or even in Winnipeg or Regina or Saskatoon, has trouble finding a way of getting somewhere other than within their community without a car. And aside from Southern Ontario and Alberta, and I appreciate and applaud PWT's innovative approach to the Red Arrow and other services in Alberta, how do you see us responding to the need in the future of this intercity and intercommunity demand for mobility with or without the 45-foot coach?
All right.
I think that in terms of electric, build the infrastructure and we can solve those problems right now. So that the infrastructure is obviously going to be a larger barrier than even within the cities. It's much easier to build on streets than it is throughout highways. But whether it's the government or whether it's a private organization that is willing to step up and build out infrastructure along the highways that can support some sort of network to get, whether it's, like you said, motor coaches or any sort of electric drive vehicle that's able to transport people to more remote places, that's the bottleneck right there. And I think that if that's developed, then the rest will fall into place.
And John.
Yeah, it's a really interesting question, Michael. I mean, this, CUDA got very interested in this space when Greyhound announced they were pulling out for sure, and there were several conversations had amongst members and things like that. I mean, from our perspective, it's collaboration. It's collaboration amongst private sector. It's collaboration with transit agencies and municipalities. And one item that we've been advocating for, and maybe not necessarily lobbying, but advocating for is for the provinces to get involved just internally kind of thing. So we're not even talking about, cross-country or intra-provincial, but really within the province. There's a lot of assets that sit unutilized. Thinking about school buses that have maybe a 10% utilization. They do a run in the morning, run in the afternoon. They might do the odd, trip to the aquarium or whatever. There's a lot of smaller vehicles that have been funded by, various forms of provincial or federal funding arms. So thinking about FCSS, thinking about, buses that the Lions Club has brought to community. There's no coordination. So there's a lot of assets that A, sit idle, B, are underutilized because there's no coordination. So you have a small community and someone needs to get to a large community, and there's a bus that sits on someone's driveway because he doesn't feel like driving today. So we've been pushing the provinces to think about, a platform. So when you start thinking about mobility as a service, maybe not so much in that realm where it's, a subscription, but how do you connect and how do you make visible all these services? So transit to us is the center of that. They have the most visibility typically in a community, and then how do you get other service providers to feed their availability into that network? So in our opinion, that's how to do it, that's how to solve it, but someone has to want to do it.
Okay. Thank you. So it sounds like we have the willingness, we have the capability, but we see the need for a strategic, coordinated approach to using these assets, either as they are now or a future with electrification. Another question from the audience.
Hi, Adriana from QTRIC, and thank you to the panel for the enticing conversations. My question is, in your opinion, which fleets in Canada should go electric? As an example, why is GoBus not going electric?
So I think, firstly, probably the early adopters are going to be the larger cities. I can't explain why a particular transit agency may choose not to go electric. That perhaps operates a coach fleet, but certainly the roadmap to full electrification, even intercity, is going to start at the city level. So. A bunch of our customers in the U.S., for example, the whole reason why we even have a large public sector business is because there's all these clusters of large populations that are working within a city area that need to get to and from the city. But so what you end up having is a short but not too short distance between them. And so these are the public transit agencies that are typically operating their own motor coach fleets. So those are going to be the ones that absolutely will be the first to go electric. So anywhere where you see a large cluster of population, where you have two cities that are extremely close together, basically in Canada, it's hard to find examples of that. Really, it's just in the GTA. So any of those transit agencies that operate motor coach fleets right now, they are going to be the first ones who should be going electric first, and then the rest can follow suit. Maybe areas like Vancouver to Abbotsford, for example, as the technology gets better and we can demonstrate our reliability in our ability to perform those services, they'll be the next, and then even smaller cities can follow suit. But really, as far as the public sector is concerned, it's the very large cities that need to get to the bedroom communities.
Terrific. Thank you for that last question, and thank you for the response, Mike. So I think in the interest of time, I'm going to wrap up this session unless I see any last minute pop-up questions. But I think through today's discussion, and I became really excited thinking about what this session could be about, and it really is about like stretching where we're at. It's about thinking beyond the opportunities and the capabilities on public transit, but how can we be thinking about the technology and the needs beyond the short distance, and what does that mean for motor coach and serving those customers outside of urban areas. We heard about range. We heard about where the capabilities in range are going and how closely they are or are not meeting the various potential needs within the motor coach industry. And I guess that's something for us to really be aware of, is that the various ways that motor coach are being used. It's different clientele at different timing and different environments, and that their range will differ depending on where their needs, and the vehicles need to be able to keep up with that, but also be of use to multiple purposes. Right? And I think that's one of the big takeaways that I got from this session, certainly around the cost. The big F word is something we've been talking about for the last 2 days on public transit. Certainly applies here on the coach as well, and even maybe more so. The larger size vehicles, the heavier weights, the longer distances, the greater technology that's going to come into play, and the cost of electrifying those assets, and how do we build the cost model into the motor coach model. And in an environment where a good portion of it is privately operated and served as well. The opportunity to follow the technology, that we are integrators in this industry, and that technology and partnering with companies like Ballard, where they have the subject matter expertise in thinking about long distance and making that available to our transit and coach operations. And then also looking beyond ourselves to the trucking industry and others that are moving forward in this area. Lastly, thinking about the skills that we'll need both in maintaining these vehicles. It sounds like that might be a little more closely aligned with public transit. Might be some opportunities for synergies there. And then lastly, the need for a coordinated thinking around asset use. These are big, expensive fleets serving a really vast territory. and how to get better use out of all of these. So with that, I really appreciate the panel coming here and letting us know about kind of the state of where we're at. We're in earlier stage than we are in public transit, but we're seeing inklings of where this can go. I'm really excited. Applaud you for your work, and I just want to invite the audience to thank our panelists for being here today.